privacy-preserving proof of personhood. I'm going to talk about what it is and why it's useful, and a couple of interesting security, AI, and decentralization problems that we found along the way. So I'm with Worldcoin, and Worldcoin is a very ambitious project that aims to build universal basic income for more than 1 billion people. And in order to do that, we basically have this hardware device. We go around the world. We will be producing tens of thousands of these. They will be everywhere. You'll be invited to download an app on your mobile phone, create your own wallet. It is all decentralized, self-custody, blockchain-based. It generates a public key that you show to the orb. Then the orb interacts with you. It generates biometric data from your irises. And based on that, we know that you haven't signed up before. Then you have this app now, and we know that you're a unique human being. And based on this, you can claim all sorts of airdrops, universal basic income schemes, you name it, all sorts of things that fundamentally require Sybil resistance, like fraud protection against people trying to get more than their allocated amount by signing up multiple times. As soon as you start handing out things for free, this is what happens. And it's hard enough to prevent just physically if you're on a marketplace handing out free samples. Doing this in the internet is near impossible because it's impossible to recognize unique human beings in the internet. We kind of also don't really want to do that because of privacy and all sorts of reasons. However, there's lots of good stuff we can build if we have something aching to it that allows us to prevent at least people from signing up multiple times. So that's the problem we had to solve, the kind of the hard problem you have to solve along the way towards your moonshot goal, and we did. So the way that works is we have this hardware device. It scans the public key. It makes sure that it's interacting with a real live human being. A common misconception about biometrics is that there's somehow a sort of password or secret that is attached to your body. Kind of isn't really, because anyone who has a glass that you've held knows your fingerprint. The thing that uniquely identifies you is that you're the only person who has that fingerprint attached to a real live human body. So making that part sure is very, very important. So that's what it does through all sorts of sensors and tricks. Then it takes a good photograph of your iris. We use irises and not fingerprints because our goal is 1 billion people. And fingerprints are only unique up to 1 million people. After that, we cannot distinguish them anymore with the best technology. Irises, however, have super high entropy, and the analysis we've done gives us the confidence that we can actually solve this problem using irises. The problem that we're solving is actually harder than the authentication use case. The iris scanners you will find for Clear in airports, for example, don't have quite the resolution we need because their problem is different. They just need to compare you against a stored representation of yourself. We need to compare you against everyone else, which means birthday paradox, which means quadratically worse. So we have our own optics in there. We have our own machine learning models to compute an embedding of these iris that then gets signed and sent to currently a central server that verifies that we haven't seen this before. And once that is okay, your uniqueness is verified, and your public key that was scanned from your wallet, we only know your public key. We know your iris code embedding, and that's it. We've never learned anything more than that. Based on that, the public key is added to the blockchain. And once that is done, you can start producing zero-knowledge claims from your wallet. And these claims, this claim in this case is, I am a real person and I have never claimed Worldcoin. Now, let's go into how this claim works. So the real person part is basically twofold. First, the public key that you sent to us is in the set that is published on the blockchain. And you know the private key belonging to this public key. Now, these two things are zero knowledge. So you prove it without revealing it. No one who sees these proofs can learn your public key, and they can definitely not learn your private key. Then we need to prove that you've never done something before. For this, we do something called a nullifier, which is basically the same mechanism that Zcash and all the other privacy anonymity-focused solutions use. What it essentially is, it assigns you a random ID, like a number gets assigned to you once for this specific context, and because the number is only used once, it cannot be correlated to anything else. However, if we see the same number pop up twice, we know that it was the same person trying to do the same thing twice. So that's the TLDR of how a nullifier works. And with that, we basically have our scheme for handing out Worldcoin to anyone on Earth who wants it, who wants to participate in this system, without having to worry too much about fraud. So coming back to the claim. Now, we've solved a hard problem here. Can we do more with it? And turns out, yes, we can. If we take this part and we turn this into some sort of a variable, then we can make the whole scheme reusable. And the way we do that is we add what we call an external nullifier. So we make this part of the context you know when you're proving. And we attach a message. So like the thing you're trying to prove the claim for provides you with the external nullifier, and then you yourself can add a message to it if you want. Both of these are public, so once you publish your proof, it will be tied to these two values. Now, what you can then do is make claims like, I have never voted in this particular poll before, or minted this NFT before, or numerous other things. Basically, anywhere you see a CAPTCHA right now, you could replace it with this mechanism. Anywhere you want to hand out things, you can do it. Quadratic voting, one person, one vote. All these schemes that are currently impossible in blockchain are enabled with this technology. And this is also where the message comes in. Like for claiming Worldcoin, there is no message attached. You just want to do the thing, and that's it. But for voting, you also need to attach the thing, the vote you picked to it. That's where the message comes in. So we've built a nice SDK and a website around it, and anyone can use this right now. So quickly, where the fun stuff comes in, zero knowledge machine learning. Like I said, right now it computes it on trusted hardware. We don't like trusted hardware, so we need to get rid of that. Instead, we can turn it into a trusted camera, which is easier, and then just send the picture to the user, and now the user can evaluate the machine learning model themselves and just send us a zero knowledge proof of correct execution. Done some experiments. It turns out feasible on modern hardware with modern proof systems. Another interesting topic I want to get into is zero knowledge digital identity. This is kind of a longer term discussion that I would love to have in the work groups. What if we don't want to just prove your personhood, but instead want to prove that you're a citizen of some country or not of some country, or your name, or like you own a particular Twitter handle or a Twitter handle with some reputation. Like how can we create protocols that maximally preserve privacy, that allow for other people to attach all sorts of attributes to your identity, like for example, academic degrees or whatnot, and allow you to do arbitrary complex claims over your identity while revealing the minimum amount of information that is required for the particular context in which you want to do this. Yes?
We have time for one question, but I'll ask you on the stage.
So how do you deal with contact lenses and the variety of FDA disapproved but possible iris color changes and such?
Regular contact lenses work fine. Colored ones get detected. There's a lot of fraud detection going on, and colored lenses and all sorts of things. People trying to sign up their dogs. Lots of fun stuff came up during field trials. My favorite is two people getting their heads right next to each other and doing their eyes like this. And when I first joined, I held the orb upside down and managed to sign up twice.
Can't I just synthesize an image of a plausible but unique iris and then use your camera to take a picture of that?
That will fail the liveness check.
What?
That will fail the liveness check because an image is not a real live human being.
How do you do the liveness check?
Variety of techniques. It's all open source, but some of the secret sauce we kind of don't share right now. But one of the things it does is like thermal imaging, measuring your pulse in your forehead, 3D modeling, time of flights, you name it.
So what if I had like glasses that have my pulse, and then you have the thermal imaging and stuff, but the glasses have pictures of my pulse on it?
Where did you get the eyeballs for glasses?
From the image generator.
It's not open source yet. Okay, we have a lot more questions, but in the interest of time, I think this could be, okay, let's do one more. As you
The liveness checking is still done in trusted hardware, right?
Correct.
So even if the recognition of the iris is run in an ML classifier with a proof and everything, the system still is reliant on trusted hardware.
As anything physical, there will be a trust element remaining. Actually, the main motivation to do this on the user wallet is that if we ever update the model with a better version, we don't have to send people back to the hardware, but they can just rerun the model locally.
Cool. Okay, the rest is